Okay, good morning class. So it will be a bit, this lesson will be a bit short because of the test you guys have written. So the homework was exercise 5.7. 5.7 was on page 117. Alright. So any problems on number 1? Any problems on number 1? Sorry, B. Okay, I will do B and E. Alright, so this is now number 1. So the question says you must calculate the unknown angle, which is alpha in this case. Yes, it is in the right angle triangle, so I can use sine cos it. But what is 4,2 relative to the angle? It's your opposite. And this here is your adjacent. So which trigonometric function uses opposite and adjacent? So tan of alpha equals opposite, which is 4,2 over 9,2. So to get alpha on its own, I take arctan both sides. Shift tan of 4,2 over 9.3. So that gives us, so shift tan or arctan of 4.2 over 9.3. It's 24,3 degrees. Okay. So C and D is fine, eh?
Yes.
E. What do they want? Oh, they want the angle alpha. So here we are told that AB is 10.6. AB is 10.6. Then we are told that AC is 6. And angle D is alpha. So if you look at what we have here, what length can be calculated here? Which angle can be calculated? Sorry? CB can be calculated, yes? If we have CB, then what can be calculated? Sorry? Angle B. Do we need CB to calculate B? No. Because we have what? Opposite and what? Adjacent. Remember, this is your triangle we're referring to. No. There's your 90. So you have your opposite and your hypotenuse. Can you see that? So I don't need CB. Okay? And if I have angle B, with I will not be able to work out theta or alpha in this. Sorry? Sum of triangles in triangle ABD. You all agree with that? The big triangle. So let's go with it. This is in triangle ABC. You don't have to write this, no? And you don't have to draw it. I'm drawing it so that some people can't see it straight away. Okay. So we can calculate angle B, or we could have calculated that angle there. Not so. If we have that angle, then we must calculate that angle thereafter and then sum of triangles. Okay. Or exterior angles goes to interior opposite. But since we called B first, so that's fine. I think that should be easy as well. So what did we say? What is that? That is your opposite. This is your hypotenuse. It's opposite of 90 degrees. So it makes it your hypotenuse. Which trigonometric function is opposite in hypotenuse? Sine. So I say sine of theta equals opposite of hypotenuse. So it will be sine. The theta angle now is B. equals opposite, which is 6 over hypotenuse, which is 10.6. So how do I get B on its own? The angle, the B, the angle B. Sorry? Arc sine both sides. So B is equal to arc sine of 6 over 10.6. Any confusion? Arc sine of 6 over 10.6. 34,47. Did I say one decimal place? Then I said 1 is 35. Otherwise it's 34,47. But ever answer the question? No. Now we're going to go with this, with a big triangle now. Remember this now, 34,47. We're going to go with sum of triangles. Okay, so it's going to be alpha. So it's in triangle ABD. Alpha plus 34,47 plus alpha is, plus 90 is equal to 180. Why? Sum of triangles, and it's triangle ABD. So alpha is equal to 180 minus 90 minus the last answer calculated, which is 34,47, gives you 55,53. 55,5. Understand? So, if you get something like that in the exam, you calculate what you can. Okay? And then you'll see things will come together. Okay? Sometimes you say you didn't make this link here in green. At least you would have gotten 3 out of 5 marks for this. Understand? Number 2. Any issues here? Sorry? Yes? In number 2 we have the angle. This is what to the angle? That is your opposite. This here? It's opposite to 90. Which trigonometric function is opposite to the hypotenuse? We say sine of theta equals opposite of hypotenuse. You don't have to write this, okay? So we go straight in. You could have gone straight and said sine 58 equals, what's the opposite? 10.8 over hypotenuse, which is x. Okay, so what do we do? Cross multiply. So that would simply be x sine 58 equals 10.8 times 1 is 10.8. So how do I get x on its own? You divide by sine 58. That cancel. So x is equal to, again on the calculator, (10.8) over sine 58. 12,74. You guys understand? Problems with B? B is right. What is the answer? 45 is correct, yes, and that's sausage triangle there. See? Huh? Yes. Sorry? Yes, I can. If it's not the problem, I don't have to do. You had a problem with it. Then say it. Don't be shy. So let's call this x1 and this x2. Okay. We're going to call it an A and a B, whatever. The reason why I broke that up there was because I can't work out that length of x straight away. So it doesn't form me any right angle triangle. Can you see that, people? So looking at this triangle here, there's no letters on there. I'm not going to put letters on either. Then your x2 lies here. Your 38 millimeters lies there. That's 90, and here you got 40 degrees. That's all. So what is 38 relative to the angle there? It's your opposite. x2 is what? Your adjacent side. So which trigonometric function am I going to use it? Yeah. So let's write this. Tan of theta equals opposite, which is opposite over adjacent. So we say tan of 40 equals, what's my opposite? My adjacent? x2. So how do I make x2 the subject of the formula? Cross multiply. So x2 times tan 40 is x2 tan 40 equals 38 times 1. How do I get x2 on its own? Divide by tan 40 both sides. That's gone. So x2 is equal to 38 over tan 40. 45,29. Okay, so this first part here, 45,2 from there to there. Okay? Now for x1, same story. Okay? Even the triangle is lying like this. That's your 90 degrees, because that's angles on the straight line. 50 degrees, 38. So x1, what is x1 relative to 50 degrees? This is your adjacent side. This is your opposite side. So which trigonometric function am I going to use here? Tan again. So I say tan of 50 equals opposite, which is 38 over x1. So what do I do now? Let us multiply. So x1 times tan 50 is x1 tan 50 equals 38. How do we get x1 on its own? Divided by tan 50 both sides. That's gone. So x1 is equal to 38 with tan 50. You do 31,89. Okay. Will they ever answer the question? No. So x will simply be the sum of these two. Not so? So it's going to be answer, which is 31,89 plus 45,29. Your answer of 77,2 or 77,18. Okay. Yes? Nice! Must have millimeters, absolutely. Carry on. Alright, so that's the end of it. So we started our trigonometric functions in the Cartesian plane. We start this. So we haven't spoken about this yet. No. Okay, so trigonometric function in the Cartesian plane. Till now you have worked with angles in right angle triangles that are between 90 and 0 degrees. We can extend this definition of the trigonometric function to say function to any angle as follows. Let P be x and y, any point in the Cartesian plane. Theta, let theta be an angle measured in the anti-clockwise positive direction from the positive x-axis to OP. Sometimes called the terminal arm. Okay, that length is your terminal arm. Better referred to as your terminal arm. We say P is in the standard position. Let OP be the radius, draw PA perpendicular to the x-axis. So what they're trying to tell you there is that if we have our terminal arm in the first quadrant, that's quadrant 1, 2, 3 and 4. That will always be your naming of the quadrant, 1, 2, 3 and 4, in that order. If your terminal arm is in quadrant 1, there's my angle. That will be your theta angle. And you see that if you need to say your angle is going to be an acute angle. If it's in quadrant 2, there's your theta angle. Okay? So there's your theta. So this is your obtuse case. Not so. Quadrant 3. From this x-axis, positive x-axis onto the terminal arm, is your theta angle. Can you see that, people? Quadrant 4. Can you see that, people? These are your two examples of your reflex angles. You all okay with that? Then, if we must construct a triangle here, we will always drop it perpendicular onto the x-axis. Can you see that, people? So if this is your point P here, P which is x and y, now drop that perpendicular onto your x. So that's again your x and your y. That's your hypotenuse, or your radius, which is r. Can you see that, people? Let's go here. That will be, of course, if that was P and x and y, this will be your x, your y, and your r, your radius. Does it make sense? You look at third quadrant. I drop this perpendicular onto the x. You always drop it perpendicular onto the x-axis, never onto the y. Okay? Again, if that is P, which is x and y, that will be your x and this will be your y. You all okay with that? The last one, same story. We drop it perpendicular onto the x, and there's your theta, there's your x and your y. And your y. Okay, is anybody that's confused? You all understand? Yes, sir. Right. So that's that. Now in example 1 on page 119, we define a trigonometric ratio of any angle theta in terms of x, y and r by. Now if this is your theta angle here, this was now your theta angle, no? This is your reference angle. Can you see that? Sorry, no? Hello? Hi Stephanie? Sorry about that. So, you see this is your reference angle. What is this to the angle? Your opposite. This here? This here? Your adjacent. So you go sine, cos, and tan. sine is opposite over hypotenuse. So it's y over r. Can you see that? This is cos. Cos is adjacent of hypotenuse. So it's x over r. You guys understand? Then what would tan be? Opposite of adjacent. So it's going to be y. You guys see that? Make a note of that quickly. Also now for the theorem of Pythagoras. It will also be evident here. The Pythagorean theorem. What does Pythagoras say? Hypotenuse squared is equal to the sum of your other two sides squared. So what's your hypotenuse here? R. So r squared is equal to x squared plus y squared. This is your Pythagorean theorem. Now the reciprocal function, you've got sine cos tan corresponds with cot, then sec and cosec. Means nothing without the angle, huh? Cosec. Now if tan is y over x, cot is x over y. If cos is x over r, sec is r over x. Sine is y over r, so that's going to be. Remember that the denominators here can never be 0, so y can't be 0, x can't be 0, and y can't be 0. And we know your r can't be 0, and x can't be 0. Okay? You know, yeah. Any confusion there? You all still with me? Until I give you a test, no? It's a total different ball game. It looks like I haven't taught you anything about this topic. Okay. Right, so let's look at this here. Example 1 on page 119. We are told P is the point negative 12 and 5. Remember in coordinate form, this is an x and that is a 1. P is the point negative 12 and 5. OP makes an angle alpha in the anti-clockwise or the positive direction with a positive x-axis. Remember what did I say? We'll always start here. Not so. Did I say that? Yes, and they do the same. No? Not because I said so. Because it's always been so. Okay. So what do we have here? What's the first thing we need to do? We need to conclude the triangle. Not 19. So draw this quickly. We'll do the sum together. Okay.
My apologies for the interruption. Elitha Jack, can you please report to Miss Benjamin's classroom? Elitha Jack, please report to Mrs. Benjamin's classroom.
Okay. So remember people, we said this is an x and a 1. Can you see that? So, if negative 12 is your x, then a negative 12 belongs there. Not so. Why? Because this is your x-axis. And this is on the negative part of your x-axis. That's why you got negative 12. Okay? You all okay with that? Then where must that 5 go? Where must the 5 then go? Huh? The dotted line is the 5. Not so. Why? Because this is your y. Can you see that? So that's going to be 5. So let's look at the question. The question says calculate the length of OP. Calculate the length of OP. So, how do you think we're going to calculate OP? Huh? Pythagorean theorem, not so. So work out using Pythagoras the length of OP. Is that asking too much for you guys? So are we going to do that? Pythagoras, we say OP squared is equal to 5 squared plus negative 12 squared. Not so? So 5 squared is 25, 12 squared 144, you add that together you get 169. Not so? The square root thereof is going to give you 30. Okay. Are you all okay with that? Any confusion? Now it says calculate the value of the 6 trigonometric ratios of alpha. What are they talking about? What are they talking about? What are they talking about, people? They're talking about the sine, cos, and tan. That's how. Yeah, I'll just take this off this way. So the six trigonometric ratio is sine, cos, and tan. They mean nothing without the angles. So what does sine stand for? All over as a hat or backwards. Or you could have written it as y over x, y over r, x over r, and y over x. You could have written it like that as well. So I want you guys to use this information now. Remember that is 13 to work out those three people. Okay? Yes? Sorry? OP? What is it? So why didn't we write 13? We say 5 squared plus negative 12 squared. Did square? I'm squaring it into 169. Square root. Right. So what is sine? Sine stands for opposite of hypotenuse. So what would this be? 5 over 30. Cos. So it'll be adjacent, which is negative 12 over 30. Tan. Opposite, which is 5 over. You guys understand? So you got sine, cos, tan. Then what do we have on the other side? Cot, sec, cos. So whereas Oliver has, he has Oliver. Are you at? At A, which is the reciprocal functions of apples. Apples. Not so. So this would simply be 13 over 5. Hypotenuse over adjacent is going to be 13 over negative 12. And cot is, of course, negative 12 over. Is there any confusion here? Alright. Let's see what they got here for us. So that's example 1. Yes, we got another one. Example 2. And this on page 120. Homework is exercise 5.8. Example 2, which page did I say now? 120. So here we are told that if P, to make it a bit smaller, P is a point negative x and negative 15, as you can see here. In the third quadrant, there's quadrant 1, 2, 3 and 4, so yes, it's the third quadrant. OP is equal to R, which is equal to 17, which is your radius, which is that length there. Beta, that's angle beta. No? Beta, it refers to the angle, is in the positive angle between OP and the positive x-axis. So I'm going to do this quickly. So first things first, I conclude the triangle. I drop it always perpendicular onto the x. That's an x and a y. So the x is x and your y is negative 50. So I'm going to calculate x. I'm going to use Pythagoras. Yes. Pythagoras. So Pythagorean theorem says 17 squared, your hypotenuse squared, is equal to x squared plus y squared, which is negative 15 squared. Don't forget the negative inside the bracket. Okay. So 17 squared is 289, I think. Let's check there. Equals x squared plus 225. You all agree with that? So how do I get x squared on its own? I take a 225 over the equal sign. So now I get 289 minus 2 to 5 equals x squared. So x squared works out to be what? Sorry? Can't be 60. Sorry? 68. 64. The square root thereof. Now remember, when I introduce square root, what must I not forget? Plus minus. So which one of the two is it going to be? The plus or the minus 8? Why the minus? It's the negative part of your x-axis, so that's minus 8. You guys understand? If the triangle was drawn this side, then what do you think your x would have been there? Positive. It's like positive part of your x-axis. Okay. Then coming to B, the B part of the question. Coming to the B part of the question, we are told calculate cot beta plus cosec beta. Now cot is the inverse, or the reciprocal, sorry. Cot is the reciprocal of tan. Tan is O over A. Alpha is A of apple. So this will be A over O. Cosec is the reciprocal of sine. So alpha is A over O. So your adjacent to this, that's your reference now. So my adjacent is negative 8 over negative 15. Plus your hypotenuse, which is 17 over negative 15. For that in the calculator, you should get an answer of 9, I think. 9 over 15, which is 3 over 4. Negative 3 over 5. I don't get it. Okay, any questions with regards to this here? Okay. Okay, I think I made a mistake. I got negative 8 over negative 15 and 17 over negative 15. Huh? They made a mistake here, no? Should have been because they cancelled 3 going to 9 3 times, 3 going to 5 times. So it should be negative 3 over 5, which is correct. Okay, so just correct that in your textbooks, okay? People enjoy the rest of your day. Good morning, class.